What's happening, dogs? It's Mr. Allen. We're solving a couple different logarithmic equations in this video. For the first two, we're solving for the base. For the second two, we're solving for the argument. But this last one's got a little bit of a twist right there with that square root. Wonder how that's going to work out. But the first step for a lot of these is actually the same. If I'm stuck when I'm in logarithmic form, let's try writing it in exponential form. And the way I do that is a little thing called loop and a swoop. All right, I start with the base. So we got x. I passed by the 4 first, so I'm going to raise it to the 4th power. Equals 81. Now, if you're doing these without a calculator, you're generally going to have some pretty nice answers, okay? So how do I solve for x? Well, we could take the 4th root of both sides, or my preferred method, I often like to use rational exponents here, and I raise it to the 1/4 power. And that means the same thing as 4th rooting, right? Square rooting, raise it to the 1/2. Cube rooting, raise it to the 1/3. 4th rooting, raise it to the 1/4. So I have 4 times 1/4, that's my power to a power rule, and I get x on the left-hand side. The 4th root of 81, let's take a guess, it's 3. If you didn't know, it's okay, okay? Basically, here's how I think about it. Well, I'm going to try like 2, 3, 4, 5 in a lot of these situations when I'm dealing with logs, because our numbers aren't going to probably get much bigger than that, especially if we're talking to the 4th power here. I'm trying to figure out a number to the 4th power that gives me 81. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's out. 3 times 3 is 9, times 3 is 27, times 3 is 81. And if the 27 times 3 is a little tricky, if I had 3 times 3 is 9, 3 times 3 is 9, 9 times 9, that's 4 3s there. That gives me the 81. You might remember the 9 times 9 is 81. All right, so that's how you do that in your head. I know it gets a little bit challenging there, but x for this one is 3. Final answer. All right, next one over here. I got log base x of the cube root of 16 equals 4/3. Okay, well, again, we're stuck in log form. Nothing to do. I'm going to go ahead and rewrite it in exponential form by looping and a swooping. So I got x to the 4/3 equals the cube root of 16. Okay, so now what? Well, remember we talked about like rational exponents and things like that? What if I rewrote the cube root of 16, okay, cube root of 16 as 16 to the 1/3? Let's try that, okay? So I got x to the 4/3 still equals 16. Well, that's 4/4, 4/3 there. And then I got 1/3 over here. So what could we do? Well, if I wanted to get the x to the 4/3, that is just awful looking right there. Let me rewrite that 3 for you guys. 4/3, there we go. If I want to get that to just be x, over here, I raise it to the reciprocal of 4. I raise it to the 1/4. Could I do that over on this side? I'm going to do it in a different color so the math pops. All right, if I raise this to the 3/4, I got to do it to the other side, so 3/4 over here as well. But when I do so, power to a power rule tells me that I got to multiply those. Well, what's 4/3 times 3/4? It's going to be 12 over 12, or 1. So I get x to the first, which is just x. Now on the other side, I've got 1 times 3 is 3, 3 times 4 is 12, or, hold up, those 3's could essentially cancel, leaving me with 16 to the 1/4. And now I got to think x equals 16 to the 1/4. So what's the 4th root of 16, or what times what times what times what, gives me 16? We already talked about it. It is 2 for that one. 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, that was a lot on this one. So let's just backtrack that real quick, make sure it makes sense of it. First step, loop and swoop, put it in exponential form, okay? Then it's hard to analyze a situation when you have a rational exponent and you have a radical. So we wrote the 16, the cube root of 16, as 16 to the 1/3 power. All right, so now I have x to the 4/3, 16 to the 1/3. If I want to get x by itself, and I have a rational exponent, we can raise both sides of the equation to the reciprocal of that rational exponent, which gave me the x, and I got to do whatever has to be done on the right-hand side. I have 1/3 and 4/3. That gets multiplied, gives me 1/4. So you got to be, crafty with your fractions as well, which I know is a scary thing. I mean, it is my 3rd favorite F word. Then I have 16 to the 1/4, so the 4th root of that is 2. Or you got to think 2 times 2 times 2 times 2 is 16. Does help to count with your fingers on some of those problems, so don't be ashamed. Don't be ashamed if you got to count with your fingers, all right? enough with those. We solved for the base. That was rough. That was tough. But hopefully, guys, that helps. Because there were some tricky ones. You might see that as like a multiple choice problem on a test or quiz, or maybe just one free response problem where they throw something like that at you. All right, second half here, guys. We are solving for our argument. So let's, once again, if I'm kind of stuck, don't know what to do, rewrite it. Loop and swoop, boom. I got 16 to the 3/4 equals x. These rational exponents seem to be coming up quite a bit in logs. So how do we deal with this? Okay. Denominator, that is going to be my root. The numerator is like my power. That's how I deal with it. So we're doing the 4th root of 16, which we know is 2, and then we're going to cube it. Okay, so I'm going to do a little side math. So we do the 4th root of 16. That gave me 2, and then we're doing 2 cubed. That gives me 8. So I get 8 right here equals x. Dunzo. Wasn't so bad. But you got to be used to your rational exponents. That's not really the logs unit, but they are used there. So it's like, obviously in math class, you're going to start having things that just come back. Like, oh, shoot, I got to remember rational exponents. Yeah, you do, right? You got to remember factoring, rational exponents. You got to know how to add and subtract throughout all math, right? That stuff always comes back. So be ready for it. All right, last one here. Oh boy, we got a square root. Perhaps we're going to rewrite that as a rational exponent in a little bit here. But let's loop and swoop it. I got 9 to the 1/2 equals the square root of x. Well, we did say square root is the same as raising to 1/2. Cube root is the same as raising to the 1/3, so on and so forth. So could we rewrite this as 9 to the 1/2 equals x to the 1/2? Oh my goodness. What do you think x is going to equal? It's going to equal 9, right? If the exponents are the same, the base got to be the same. Kind of almost like, there isn't really the one-to-one property in that regard, but if you do have the same exponent on each side, the base has to be the same, so we're going to have x equals 9. And you could, if you really wanted to, square both sides, cancel it out. You're going to get x equals 9. Okay? So there we go, guys. I know those are some tricky problems right there, but hopefully that helps. If you have any questions, pop in the comments there. Like the video, subscribe, all that good stuff. And if you have any questions, requests, I don't even know what I already said. But if you got them, put them in the comments. I'm happy to make some other videos for you guys if there's something that you're not finding, or maybe I'll link it there for you if I have one already and you just couldn't find it. Otherwise, thanks for watching, you guys, and have a wonderful, wonderful day. See you later.